Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever on this glorious day. As you may have noticed way up here, it is indeed Pi Day on the day of this recording. So in honor of this great day, we play the Pi song. We look at many representations here of pi. And then we get right to the binomial, we got ahead of ourselves, the binomial distribution part 1. Not sure how many parts there are going to be because it's a bit wordy. So bear down, get ready for the excitement. And by the way, the relationship between pi and the binomial distribution is, there isn't one. Okay, so far we have considered general discrete random variables, and now we're going to talk about a special type of discrete random variable that goes with sampling with replacement. It is the binomial probability distribution. So binomial experiments. Now, this is really important that all this vocabulary and information, bear down, take some notes, do whatever you have to do, because you really got to understand what's going on here. Binomial experiments basically are experiments where there are two possible results, success and failure. And if we repeat this experiment in a number of independent trials, it's called a binomial experiment. And if our only probability of a success is yes or no, then it's a complementary, they're complementary events. So if the probability of a success is p, then the probability of failure is 1 minus p. And as always, the random variable cap x is the total number of successes in n trials. So x can be a representation, or represents the different kinds of successes, or the different, I shouldn't say kinds, the different numbers of successes. So let's take a little easy experiment here. We got a spinner. We have 3 sections that are blue and 1 section that is white, and they are all equal sections, and the probability of each of them is equal, which makes them each 1/4. So the chance, if we spin it, of finishing on blue is 3/4 and on white is 1/4. So if we call the blue result a success and the white a failure, then we've got a binomial experiment. So if success is 3/4, probability is 1 minus success, or 1 minus 3/4, which is 1/4. So let's start by considering that we twirl the spinner 3 times. Now this page is going to get very crowded. That's why I put the boxes up so you weren't distracted as we go through each section. Okay, so if x is the random variable x, let the random variable x be the number of successes or blue results. Here's all the possibilities if we spin it 3 times. And you might think it's a little weird because there's 4 possibilities with only 3 spins, but it makes sense if you think about it. We can either be successful on 3 spins. We can be successful 0 times, 1 time, 2 times, or 3 times. So let's find the probability that the random variable x is equal to 0, that none are blue. That means 3 whites in a row. So that's easy. That's 1/4 times 1/4 times 1/4, or 1/4 cubed. And all of this is represented here on this tree diagram. That particular one are these branches right here. Let's say the probability that is x equals 1. There's 1 blue and 2 whites. And here's all the different combinations that we could have. Blue, white, 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 blue, white, or white, white, blue. Okay? These are the 3 branches where the probability would be 3/4 times 1/4 squared. And that makes sense for each of those, right? Probability is 3/4, and then 2/4, or 2 whites would be 1/4 times 1/4, or 1/4 squared. And that combination occurs 3 times. So there's 3 different branches here, 1, 2, 3, where this probability rules. Same thing for x equals 2, except the 3/4 is squared because we have we're counting the probability or the possibility of the two blues. And then winning all the time would be 3/4 cubed. Of course, that would be a blue, a blue, a blue. Okay? So hopefully you're starting to notice something here. Probability that x equals 0 is 1/4 cubed. Then 3 times 1/4 squared, 3/4 to the first power. 3 times 1/4 to the first, 3/4 squared. And then 3/4 cubed. Coefficient here, 1. Coefficient here, 3. Coefficient here, 3. Coefficient 1. Our first term is cubed. Then the first term is squared. Then it's to the first power. And then 1/4 is really here, but it's to the 0 power. And then if we go with our 3/4, it's 3/4 to the 0 here, to the first here, second here, and cubed here. Can you say binomial expansion? Yes, I think that you can. Okay, so we can use the, wrong click. Let's cancel that. Sorry. Back it up like a Tonka truck. Okay, so we can use this knowledge to our advantage. This suggests that the probability that the random variable x equals a specific value, either the 0, the 1, the 2, or the 3. By the way, that's always a little confusing. This represents, this is all the different possibilities of success. And then we say that equals the individual one of these, the 0, the 1, or the 2, to the 3, is equal to 3 choose x, 3/4 to the x power times 1/4 to the 3 minus x. That's the binomial expansion, boys and girls. And of course, the sum is going to be that expansion, which will always add up to 1. Will always add up to 1. Okay? So let's just do one quick experiment here, one example, and then we'll pause the video, let your brain take a break. Okay. So this is just a review here. 9/10 times 9/10 plus 1/10 to the 5th power. It is a binomial expansion. So that would be equal to 9/10 to the 5th power, coefficient of 1, and you can either do you can find your binomial coefficient this way. You can think of it this way. If you remember the n choose, you have n choose 1, n choose r. It's real simple. Or you could use Pascal's triangle to get these coefficients. This is more efficient and quicker than Pascal's triangle. I think it really is up to you. So this would be 5 times 9/10 to the 4th power times 1/10 to the 1st power. Next coefficient is 10, so plus 10, 9/10 cubed. Remember binomial expansion? Thought it was going away? Never! 1/10 squared. Again, remember, since we're expanding to the 5th power, our exponents will always add up to 5, plus 10. I'm going to try and write smaller because I'm going to run out of room. 9/10 squared, 1/10 cubed. We're getting there. Plus 5, 9/10 to the 1st, 1/10 to the 4th, plus 1/10, oops, I forgot the 4th, 1/10 to the 5th power. And we are done like a bun, okay? All right, so an archer has a 90% chance of hitting a target with each arrow. An archer, that's a guy who shoots a bow and arrow, right? So this is a bow, and we have an arrow, and we have a target over here in case we don't know what we're talking about, and we pull it back, and it's like bang, zoom, and it hits the target or it doesn't. So this archer has a 90% chance of hitting the target. If 5 arrows are fired, determine the chance of hitting the target. Twice only, at most 3 times. Okay, twice only, and at most 3 times. Okay. So 90%, well, that's 9 out of 10. So this is the success This is the failure. So how do we figure that out? The probability of success with each arrow is P equals 9/10. We just talked about that. Okay? So if we let X be the number of arrows that hit the target, then the expansion in A gives the probability distribution for X, right? So what does this mean? How can I tell? This means this is the probability that our random variable X equals 5. 5 hits. This would be 4 hits right here, 1 miss. 3 hits, 2 misses. Remember, these are the probabilities. If there's 3 out of 5 arrows, if there's 3 hits, it's going to be 9/10 times 9/10 times 9/10 times 1/10 times 1/10. That's a probability times this 10. Okay, and that's what we saw on the previous slide. Okay, so this would be 2 hits, 3 misses, 1 hit, 4 misses, 0 hits, 5 misses. Okay, so what's the probability? So let me move B sub I down here. That it hits twice only. Well, that's the probability that the random variable X is equal to 2. Well, that's right here. This is the only place where we have 2 successes. So that would be the probability that our random variable X is equal to 2 would be equal to 10 times 9/10 squared times 1/10 cubed. That's a perfectly good answer. But if you had your calculator, you would see that that is approximately equal to 0.008 to 3 sig figs. Okay? So here, for the second one, at most 3 times. At most 3 times. So 3 is included. So what is that? So that's the probability that our random variable X is less than or equal to 3. That the success is 3, you hit the target 3 times or less. Another way to think about it would be, okay, X, the random variable X equals 0, 0, that's horrible, 0, 1, 2, or 3. That's what that means. Okay. Well, where are all of those? Well, that's all of the successes of 3 or more. So that's X equals 0, X equals 1, X equals 2, and X equals 3. So that's this one, this one, this one, and this one. And let's see if I am able to select and move this. Hold on. Hold the phone, Chuck. Okay, I'm going to try and copy it and paste it. That's not working. Let's see if I can just move it. Oh, I can. So I'm sorry, I just moved it down here. That's what that equals, that X is less than or equal to 3. All of these, 3 successes, 2 successes, 1 success, or 0 success, meets this criterion right here. If you had a calculator, you would see that that is approximately equal to 0.082. That's the probability that that would happen. Okay, that was part 1. I'm going to stop this video. We'll do part 2 next. I am almost out before, I think, well, since it's Pi Day, let's see how we're doing on the digits of pi. Now, I am out.